Hello and welcome to Algebra 2, Chapter 7.3, Power, Functions, and Function Operations. So first of all, just a little review of functions. And so, we use functions all the time. You can think of it just like an equation. The deal with a function, though, is if you graph it, it's going to have to pass the vertical line test. So we're talking lines, unless they're vertical lines, or we're talking parabolas that open up and down. And so the four basic operations you can do with a function, add, subtract, multiply, and divide, you're just doing that with those two equations, or those two expressions. So for instance, here under addition, we have f of x plus g of x. So if here is f of x and here is g of x, when you go to add those together, you're just adding like terms. Okay? Or when you go to subtract them, here is f of x minus g of x. You're going to distribute that minus sign. You're going to treat them just like polynomials. Okay, when you get to multiplying, here's f of x times g of x. You're going to distribute. And when we get to division, and we haven't talked a lot about division of polynomials yet, but you have f of x divided by g of x. And at this moment, we're just going to leave it just like that. And so what we really want to concentrate on here is the domain. And so the domain, remember, is your x values. And it's almost as important to what x values can it not be as to what x values can it be. So remember, if you have something like a line going like this, the domain here is going to be all real numbers because every x has a corresponding point on that line. Same thing as if you had a parabola, domain is going to be all real numbers. So it gets to be, though, we talk about some rational equations. So what if I have something like this? So there's actually something called an asymptote that lies in here that is going to be undefined for x. So for example, if we come back up here to this h of x, if x is a negative 1, then we're going to have 0 on the bottom, and we cannot divide by 0. So we would say that it's all real numbers except negative 1 because it can't be that value. So a power function is a function that has the form y equals a, x to the b power, and a is going to be a number and b is going to be a rational number, meaning it's not irrational, so it's something that can be written as a fraction. And we are going to do several things with power functions. Okay, so the first thing we're going to do is go back to those basic operations of functions. And so here I have two functions, f of x and g of x, and the first thing we want to do is find the sum. So the sum, if you wrote it out, it would be f of x plus g of x. And if we did a little bit of substitution, that's 3x to the 1/3 plus 2x to the 1/3. And if we add those together, we get 5x to the 1/3. So there is the sum of them. So the next thing is the difference. So this would be f of x minus g of x. Now notice g of x minus f of x will give you a completely different answer, so make sure that the order is correct. And this is going to be 3x to the 1/3 minus 2x to the 1/3, which leaves us with just 1x to the 1/3. And we want to talk about the domains. And so either of these could you put in any number for x and get an acceptable answer, get a real answer out of it? Sure, because any real number to the 1/3 power is still a real number. So then if you times it by 5, you still get a real number. So both of these have a domain of all real numbers. And so what that means is you can put in any x you want and you will get a real value out. Okay, so let's talk about the product. So the product is going to look like f of x times g of x, which is going to be 4x to the 1/3 times x to the 1/2. And you multiply those, we're going to get 4x, and hold on, I'm not done yet. When we multiply, what do we do with our exponents? We add them. So 1/3 plus a half. Let's see here, times 2 times 2 times 3 times 3. We get 5/6. All right, so 4x to the 5/6. And my domain, we're going to do our domain here as we go along. Are there any x values that I cannot put in for that? Nope, I can put in any x value. And so then my domain is all real numbers. All right, so let's look at the second one here. All right, so the quotient. So this is going to be f of x divided by g of x. All right, so this is going to be 4x to the 1/3 divided by x to the 1/2. And we get a 4, and we get an x. And this time we're going to do 1/3 minus 1/2. Because if I'm dividing, then I'm going to subtract. So that's 2/6, and that's 3/6, and that's negative 1/6. And if we write this correctly, the 4 stays on top, we get x to the 1/6 on the bottom. And so then the question becomes, what is its domain? Well, so if I'm looking at it, first of all, x is on the bottom. So if x is 0, does that work? It doesn't, because 0 to the 1/6 power is still 0, and I can't divide by 0. So it can't be 0, okay? If x is any positive numbers, would that work? Well, sure, 1 to the 1/6 is 1, 2 to the 1/6 is some number, and those will all work. The question really needs to be, can x be any negative numbers? Because remember that x to the 1/6 is the same thing as the 6th root of x, which is an even index. Can you put a negative under an even index? You can't. That's just like putting a negative under a square root. You can't. So x can't be negative. X can't be 0. So we are going to say positive real numbers. Okay, now that's the numbers that would work there. So the next thing we're going to talk about is called a composition of functions, and it's to take a function in a function. And so lots of times you'll see it denoted like this, f of g of x. You might also see it denoted f of g of x, like that. Some people call it fog. It might be evident why. And so what you do is you replace, typically, you'd have an f of x. You're going to replace that x with the g of x expression. Okay? And so this says the domain of h, which is our overall composition function, is the set of x values such that x is the domain of g and g of x is the domain of f. And so I'll talk about that here in 1 second. First of all, we're going to find the following composition. We're going to do f of g of x. So here's what you do. Replace g of x. So we have f of, well, what is g of x? It is x squared minus 1. So now I have f of x squared minus 1. And remember, when you evaluate, you plug in this number for x. So this is going to be 2 times x squared minus 1 to the negative first, which if we move it to the bottom would look like 2 over x squared minus 1. And that might be the way to write it so that you can see it like that. All right, so there is f of g of x. So the next thing we want to do is find the domain. So what can x not be? And what you're really looking at is the fact that you have a fraction and you can't have 0. You can't have 0 on the bottom. So if x was 1, then you'd get 0 on the bottom. And if x is negative 1, you'd get 0 on the bottom. So we're going to say it's all real numbers except 1 and negative 1. You got to have both of them in there. Okay, so again, we're going to find a composition. This time we're doing g of f of x. So I'm going to replace f of x with what f of x equals. All right, and then I'm going to evaluate g. I'm going to replace x with 2x to the negative first. So this is going to be 2x to the negative first squared minus 1, which is going to be 4x to the negative second. And we're going to put that x squared on the bottom. Remember, the exponent only goes to what it's touching, so the 4 stays on top. So what's the domain here? Again, I have a fraction, and so on the bottom we can't have 0. And so what would make x be 0? Just 0. So our domain is all real numbers except 0. Okay, I do want to say one other thing here real quick. We've only been going off, the final answers domain, but when you do compositions, you have to look at your domains to begin with. And so if we look at our domains to begin with, we're going to look at F's domain to begin with, because that's the one that started inside. What number can you not have here? Because remember, this is 2 over x. So we start out with, you can't have 0 in there. Okay, what about g's? Well, g's, you could have anything. You can put in any number and square it, and you still have a real number. So when you do these, and I'm sure we're going to have some more examples that come up that this is a little more important on, that you have to look at what your domains are to begin with, and then you will kind of look at your final product. But because we start out with this can't have a 0, then we have to end with this can't have a 0. All right, if you need some extra examples, you can go ahead and watch the extra example video. And if not, I will see you in class next time. Have a good day.